it's 11. So I guess we can start. All right. So good morning, evening to everybody, everywhere in the world you might be. So welcome to the 8th annual workshop on everyday virtual, augmented and mixed reality workshop with WEVR 2022. I'm Adalberto Simeone, talking to you from Belgium. Yeah, we are now at the 8th edition of this workshop. So we are close to the 10th anniversary. So it's been, a long set of years that we have been running this workshop, and this year's edition has been organized by myself, Benjamin Weyers, Svetlana Bialkova, Song Zhang, and Ji Yang, who I want to thank, and if they are in the audience, thank you again for contributing your time and effort to organizing this workshop. So this time the schedule is perhaps a bit shorter than previous years, but we have in the first hour a keynote from Christoph Borst, professor at the University of Louisiana at Lafayette. And then after his keynote, there will be a short break, and then the workshop will continue with the 4 papers that we have this year at the workshop. Okay, so without further ado, I will just introduce Christoph. For those who don't know, he is a professor at the University of Louisiana at Lafayette and the founder of the Virtual Reality Lab in the School of Computing at this university. He has worked with national and international gigabit initiatives like US Ignite, Ignite SA, Mozilla Gigabit, and various smart gigabit communities to prototype remotely guided educational VR approaches on emerging gigabit networks. Dr. Borst's ongoing work considers enhanced VR sensing to detect and respond to student attention level. Dr. Borst obtained his PhD from Texas A&M University in 2002 for research on naturalistic hand-based interaction VR, and his keynote will be on these themes. All right, so I will stop sharing my screen, and yeah, Christoph, you can share yours.
All right. All right, you see the presentation?
I do, yes.
All right, thank you for the introduction. So the presentation will summarize some work we have done on remote educational VR, and also some ongoing work on enhanced sensing for improving educational VR, and especially eye tracking. So now I need to. Okay, so before I start, I wanted to put 2 plugs in. One is that the presentation is based on a book chapter that we have submitted to the Springer book on everyday VR. And Benjamin might be able to tell you more about that, but hopefully if things work well, this will be out sometime this year. And so you can find more details about these topics in this book chapter. Also, some of us are involved in a special topic in Frontiers in VR that has a pending journal paper deadline in about 2 months. So if anyone's interested in putting together a journal paper about everyday VR, please consider the Frontiers in VR special topic on everyday augmented and virtual reality. All right, so I know people here have different backgrounds. Some are very application oriented. I'll tell you a bit about my background so you know what angle I'm coming from. And then I'll summarize two studies we did over the past few years about remote VR for education. One of them brought virtual field trips into high school classrooms, guided by remote live experts. Another one was a study of Mozilla hubs being used for a university course. And the main thing you'll see, I think, in these studies is there's some good promise for remote educational VR, but there are also some problems with current technology if people are receiving this kind of experience in their homes, out in the wild rather than in a controlled setting. I'll talk about some work in progress on sensing and responding to inattention, or most of it is about how we use eye tracking to improve educational VR. And then I'll try to summarize with some reflections about the challenges and practical considerations for making everyday educational VR use successful in the long term. So what is still needed to make it work? So my background is that I have a computer science background, and I started a VR lab about 20 years ago. And you can see here different applications that we have worked on. And most of them involve interactive graphics of some sort, some of them with large scale and specialized VR type devices, and some with more conventional smaller scale devices. I want to talk about one in particular a little more, and that is this VR geosciences interpretation system in the middle on the bottom. All right, this is an image from about 15 years ago at a geosciences convention. We gave a demonstration of remotely guided VR for interpreting geosciences data sets. So here there's a image of a terrain, and there are some interpretations being placed on the terrain. And the idea was that a geologist could collaborate with someone else remotely to review the interpretations as they are being done, or they could guide someone to understand the data set or interpretation for educational purposes. At the time, we did not immediately think of this as everyday VR, because you see this involves some big equipment, and devices were expensive at the time. But you see this display over here. This is a small scale display built out of some commodity equipment. And we thought about how do we make this work in offices or in small, comfortable spaces. And at the time, I envisioned that everyday VR might look something like this. So we worked with these mirror-based fish tank displays. So the idea here is there's a conventional monitor with some stereo capabilities placed above a mirror, and the user wears shutter glasses. And so instead of being immersed in a large VR environment, they see a small scale 3D environment here, and they can reach in and interact with this environment. So this brought the cost of the VR display down a lot. And there are certain tasks where you don't need to be fully immersed. You can focus on a small space, and this concentrated all the pixels in a small area, so you would get, at least in a small area, a higher quality display. But when we presented this to the geologist we worked with, it was clear that he really wanted to be in the headset walking around his data set and seeing it very large. So that's just one person's opinion, but it was very clear that in his case, he liked this immersive VR with a headset. At the same time, it seemed that VR had not succeeded, for example, in the oil industry, where they look at subsurface features and do some geological interpretation. And it appeared to be, besides the cost and the effort of maintaining these large systems and bringing people into the systems, it seemed that one of the main reasons was the software and interfaces were not available to really let them do their work. So they had highly developed interfaces for geological interpretation on a desktop, and then in VR they could see their data sets, but they didn't have very good interfaces to do their interpretation. So I became an interaction-focused researcher at that point. Now jumping ahead about 10 years, we know that what happened now is that due to new emerging headsets, we now have for a low cost, we get a sufficient quality to go back to doing immersive VR cheaply and in the wild. That is, we can now bring it to schools or use it in homes. We have the quality and cost at the point where that works well. And at the same time, networks were getting better. So we have gigabit network access in more places. So we saw this as an opportunity to study VR in schools to do remote guided VR for education in schools. For educationally, the motivation for doing this is to increase access to field trip-like experiences. So field trips involve some scheduling and geographical constraints, and similar experiences might be created in VR and provide easier and lower cost access without the scheduling, so many scheduling and travel problems. Additionally, we saw the networking as a way to stream remote subject matter experts into the field trip experience, so students could still have that benefit of an expert instructor that they may not get usually in their school. Additionally, VR allows additional visual elements or visualizations to be added into the environment that may serve an educational benefit compared to real field trips. In 2020, the motivation changed a bit. Now everything went remote. So remote became standard, and we started hearing about Zoom fatigue. So I suffer from Zoom fatigue. I'm on Zoom right now, but for me, I think one of the factors of Zoom fatigue is the delays involved in the communication, and it makes me not speak the same way when I'm interacting with someone. It reduces the interaction. There's some other speculation about what are the factors of Zoom fatigue, like the social stress of being on camera and always seeing your own image looking back at you. So several of us, I think, at this point, were considering that VR might be a way to address some of these problems by having meetings in VR. So our framework for remote field trips was called Kvasir VR, and Kvasir is a person in Norse mythology who is very wise and travels around spreading knowledge. So we thought this was a good name for a remote educational system. And I'll play you a video to show you what the experience looks like. These are two lab assistants, but in this case, the lab assistant on the right is playing the role of a student. And in the background, you see the VR environment that he is immersed in. And this is a field trip of a solar plant. And this is a model of a real solar plant that is at our university. And that's at some point, students would take real field trips to the solar plant, and we wanted to reproduce the experience virtually. On the left, you see another lab assistant playing the role of an instructor being live streamed into the VR environment, and he is represented by a mesh that is captured by a single Kinect camera. So he's somewhat 3D, but if you were to look at him from the side, you would see that his back is missing. So I'll play the video.
These are the solar collectors. The purpose of a collector is to gather thermal energy by focusing sunlight on this big pipe that runs along the center. This heats up water that gets pumped through the pipe. Can you trigger that pipe up there to see? Now you're seeing the sun's rays shine down on the collector's mirrors and being reflected onto the pipe. The sun's rays are heating up the water that's moving through the pipe.
And I'll skip ahead to another part of the video that shows some two-way interaction between the two people.
And what do you think this green liquid flowing from the condenser is?
Warm refrigerant?
Well, actually, the important part to notice here is that it's refrigerant that's been cooled down and condensed into a liquid. So it has entered as this refrigerant vapor, and it's going to leave as cooled liquid refrigerant.
So I wanted to show some two-way interaction because this is the value of having a live guide there instead of a canned activity, that the live guide can correct misunderstandings and answer questions in a more natural manner. I'll show you the interface that the teacher uses. And in this case, the interface is not immersive. So we wanted to optimize the student experience. The teacher experience is perhaps a little less less exciting, but the teacher uses a mirror world interface, which means the teacher sees a sort of a reflection of themselves in the VR environment on this large television. And here's the Connect sensor that is scanning the mesh and streaming the mesh into VR. And there are some indicators on this display of what exactly this remote students are seeing. And there are some webcam images being streamed from the students, and these are positioned such that they work as gaze targets. That is, when the teacher looks at these video images, then the students perceive that the teacher is looking at them. So I'll show you a video of this.
Here we'll see where the vaporized refrigerant goes and what it does. Ren, can you click on this turbine so we can see? Right. Here you see the vaporized refrigerant has a high pressure and it's being pushed through this turbine, which is causing it to spin.
So this interface was described in some detail at this everyday VR workshop about 5 years ago. In terms of the student experience, when we went to high schools, we had groups of 4 or 5 students sitting on a row looking at laptops. We wanted to keep them seated so that there were no risks of them tripping over cords or bumping into objects. We wanted to make the interface very simple, so it was a 1-button interface with 1 controller. They could point and click at different objects in the environment, and the teacher would tell them, you click here or click there. And they could point, one person could initiate a teleport to a next educational station. And we used a step teleport because we wanted to minimize the chances of motion sickness. And I'll show you what it looks like when the students are sitting there in the classroom experiencing this virtual field trip.
The refrigerant is heated up by the water, causing it to boil. Let's head over to the turbine area behind me. This is the condenser. Here the refrigerant vapor is cooled back to a liquid so that it can start the cycle all over again.
By the way, I apologize if you hear some beeps from my computer. I seem to have left Discord on. I seem to have left the beeps on in Discord. Okay, so we conducted some formal studies with 203 high school students in various studies, and we did some additional interface focused studies with some university students. But the main study that I am summarizing here is from the IEEE VR conference in 2018, and we had about half of the students experience the live guided VR, and we had about half of the students experience a pre-recorded teacher, and we tried to mimic the experience as closely as possible, but of course there couldn't be the two-way interaction between the teacher and student the way there was in the live guided case. And we tried this in 2 different types of classrooms. In one case, it was like the one you saw in the video where there were some other activities going on in the classroom, and in one case they had a dedicated quiet room. Additionally, we did some technical demonstrations and long-range deployments. For example, we did a deployment where we had students visiting a library in Chattanooga, Tennessee, and the instructor was in Lafayette, Louisiana, and for 1 or 2 weeks we guided students through these field trips to see if this would work across a long range. All right, so the results of this study we presented at IEEE VR. Some of the main results here is, in terms of the learning gains, that is pre-test to post-test learning gains, they were very good depending on the conditions. So when the students were in a dedicated classroom and there was live guidance, they were very good and substantially better with live guidance than with the sort of pre-recorded standalone version. There was, especially for the live guided version, high reported co-presence and engagement, and several other ratings that we received from students. Minimal discomfort was reported, so we didn't hear about motion sickness and things like this. And this is in contrast to the next study I'll discuss. We had control of the devices here. Most positive aspects reported by the students were the interaction and the 3D viewing and comments related to the sense of presence. Most negative aspects were some visual glitches or problems with the teacher imagery. So the using one single connect to scan the teacher mesh does not produce the best teacher imagery, but we wanted to make this using commodity devices and easily deployable. But there's a trade-off here. The pre-recorded version was faster, that the students spend less time in the pre-recorded version, and this scales up very well because they don't need to schedule time with a remote teacher, and they don't need to have a network set up. So we're left with this question. Why did the live guidance work well? And could, for example, a sufficiently advanced AI teacher match the quality of the live guidance? I don't have an answer to this. I think it depends on what was the role of co-presence here. That is, if the students performed well because they felt a live teacher and other students were there, perhaps no AI will give us this quality of result. But on the other hand, if it's just a matter of having better interaction between the student and the teacher, eventually we may be able to reproduce the quality using some sort of agent. However, so our experiments were cut short here. We had to exit the schools 2 years ago. We could not do our follow-up studies. So our friend here who has infected a lot of us. And our classes went remote, and I know Adalberto and maybe some others here were decided to teach classes using a tool called Mozilla Hubs, which is easily accessible from the web and works on many devices. So we had a course at our university that was taught in Mozilla Hubs during the early stages of the pandemic. And so one of the research assistants studied the student experiences in that course. And so most of you know what Mozilla Hubs looks like, but I'll play a clip here. So this is a teacher avatar, this describing a PDF presentation that is uploaded to Mozilla Hubs. And there are videos placed here that can be triggered to augment the lecture. And here's a live video stream. So if the students prefer to actually see a video stream of the instructor, they can see this here. Most of the students are here attending from desktop displays, but there's a student in the lower left that appears to be attending with a headset, because you can see the head movement and you can see a bit of a hand there from a controller. So over the course of the class, the students switched between using desktop VR and using headset VR, and we gave various questionnaires at different weeks throughout the semester. So, and for example, in 1 week, some students would try desktop and some would try headset, and then they would answer a questionnaire about their experience. And then in another week, their roles would be flipped and they would answer the questionnaire using the other type of attendance. There was a week in which students presented themselves using VR interfaces, and they rated that experience. And then all the way at the end of the class, the students reflected on their entire semester experience, rating what they think worked well or didn't work well. So we'll see some of those results. So overall, the ratings were positive in several respects, both for desktop and headset viewing of Mozilla Hubs. However, in the case of headset viewing, the experiences, the quality of experience seemed to vary widely. That is, there were some students who gave very high ratings and some who gave very low ratings. And this appears related to discomfort or simulator sickness. So by the way, this is a small class of 13 students, and they are computer science students. So they don't reflect the general population. But they are what we might think of as early adopters. And if we cannot make this work for early adopters, right, I don't think we can make this work for the general public. So regarding the discomfort or simulator sickness, there were very high correlations between how students reported symptoms on an SSQ type simulator sickness questionnaire. High correlations between that and other ratings, for example, ratings of overall experience. And so we looked at that in some more detail, and we found that there were 5 students who reported substantial symptoms overall, and those 5 students accounted for almost all negative headset ratings. And then when we looked at what types of symptoms they reported or what kind of answers they gave to open-ended questions about their symptoms, that they seemed to reflect mostly general discomfort. So this was not motion sickness. This was something like fatigue from the headset or the pressure from the headset on the face. So largely ergonomic type problems. Some of them removed their headsets. So a few of them removed their headsets due to physical discomfort or in one case, nausea. Some of them removed their headsets briefly because there were external distractions or because battery power ran out or because there was some problem with the browser that was displaying Mozilla hubs. So we asked them about which kind of technical problems they encountered and which kinds of distractions they encountered while using VR. And primarily the technical problems involve audio or video glitches or problems with the display device. The distractions were less reported, but the main distraction that was reported was external noise from, for example, from people or pets. So there were some external distractions causing problems. At the end of the semester, we asked them to rate their sense of belonging to a university and their motivation for different kinds of remote instructional technologies. So they rated other technologies like one-way video and multi-way video, and this was based on most of them experiencing some of these technologies in other classes. And you see that VR and headset rates pretty highly here. So these ratings are from low to high, left to right. VR and headset is pretty far on the right. One-way live video or pre-recorded video tends to get lower ratings. Surprising result here, and I don't know why this happens, is that VR on desktop was rated very low for motivation. This was a bit of a surprise because in terms of other ratings, VR on desktop, typically VR on desktop rated reasonably well, but in this case, for this particular question, it did not. So throughout the semester, we made a list of comments that students gave us about why they think VR should be used or why they think VR should be avoided. And then at the end of the semester, we asked all students whether or not they agree with these comments made by their classmates. And when we asked them if they agree with these reasons for using VR, you can see agreement is pretty high, and especially they like attending class without traveling, which you also get with other technologies like Zoom. They like the level of interaction, which is different from other technologies. They like not showing their real face or surroundings, and it appeared to give them some more confidence. But you see overall, they tend to agree with these positive comments made by their classmates. For the negative comments, reasons against using VR, they don't agree. Overall, they don't agree very much with negative comments of their classmates, but they do agree with comments about technical problems or performance requirements or glitches. So that seems to be the main negative aspect. And down here at the bottom, you have concerns about others seeing your movements. And so this is sort of interesting because they reported elsewhere that they don't like being seen on camera, but it seems that they do not mind having their tracked motion being transmitted. So this relates to this relates to a little bit to privacy. You know, they seem to prefer their tracked motion being transmitted than their video images. And finally, we asked them how would they like to attend a class delivered in VR. Would they like to use headset or desktop? And most of them preferred some kind of mix, only one each, saying they would prefer to always use desktop or always use headset. So we can expect that we would like to deliver, we would like a VR tool for this kind of activities to support both desktop and headset viewing. All right, so there's actually a lot more information about ratings in our paper last year in Frontiers in VR. But just to give a quick summary of the main points here, headset VR is beneficial for those students who are comfortable, but there seemed to be some problems when they reported some discomfort or ergonomic problems. And we think this is due in part to the fact that they had to set these up in home environments where they had varying types of equipment, and they had to go through some hurdles to set everything up. And this is in contrast to our study in high schools where we had control of the equipment and we could set everything up and make sure it was running well. Desktop viewing looks like a viable alternative. Overall, it was rated positive, but I showed you there was an exception when we asked them how motivating it was. And students seem to, they don't want to be on camera. Most of them, they seem to like using avatars instead. So now jumping ahead a bit to work in progress. So there are various research prototypes and also consumer devices that are adding more kinds of sensors, such as heart rate sensors, facial tracking, EEG, eye tracking. We've been focusing mostly on eye tracking and how we can use eye tracking to improve educational VR and trying to see what the effect is on users and on teachers. So I will show you first, I will go through these a bit quickly. I will show you first 3 different simple uses of eye tracking in educational VR. So in an IEEE VR poster, we showed about 8 or 9 different types of visual cues that would appear when the student, based on eye tracking, is detected to look away from a object of interest. So here the effect pops up when the student looks away to try to restore, tries to restore attention. There are only 4 displayed in this video, but we have about 8 in that poster. We have an experiment ongoing that compares these visual cues to see which are most effective and which are subjectively preferred. We have some preliminary results, but I'm not going to present any results here today. Yeah, I skipped one by accident. In this case, we have an environment that is responsive to eye tracking, and what you see here is a pedagogical agent, which consists of recorded clips of a presenter recorded using the Microsoft Connect device in with our Kvasir framework. The gaze trail that you see here is usually not visible to the student. This is just added here for illustration in the video. This shows where the viewer is looking, and the agent here responds differently depending on what the gaze does. So the agent is trying to point to a deck crane and an oil rig and is presenting information about the deck crane. And if the student looks at the deck crane, or continues to look at the teacher, the presentation continues. But if there's a problem, in this case, the student being distracted by in this case, they have a device that looks like a cell phone in order to introduce a distraction. If the student gets distracted, the agent can, for example, pause rewind a bit and replay, or play some additional clips, encouraging the student to look back at a certain location. And so the agent responds, and we also have a experiment that is currently we're still analyzing some of the data that considers considers preferences, and also if this affects learning. So based on what I've seen so far, we see there's a preference for the agent to rewind or play some additional clips. If the agent just pauses, that can seem strange to the student, but and the rewinding and replaying seems better than just sort of ignoring the distraction and just continuing. So, all right. So, and here's another way to use eye tracking, is to have shared gaze in a remote collaborative system. So here you see an interpreter adding some drawing on a terrain. So this is again some kind of annotation system. And you see the gaze trail. In this case, the user sees the gaze trail that represents where the remote user is looking. And so the interpreter here understands immediately if the remote user is looking at the right place, so that this is to aid the discussion of what's going on in the environment. So if the other person is not looking in the right place, he can pause, or he can communicate verbally to try to get the other person's attention, or try to clarify some misunderstanding. So this was presented at a everyday VR type workshop at the mentioned computer conference 2 years ago, and also at IEEE VR 2 years ago. We compared various visualizations of shared gaze. So we looked at a gaze trail, we looked at a heat map, arrows, little discs. So we looked at different kind of visualizations, and I'll show you a still picture of this. This is the gaze trails viewed by a teacher for supervising 5. This is simulated, but this is 5 simulated. By simulated, I mean pre-recorded. This is 5 gaze trails, and we looked at different visualizations to see which ones were preferred. And this is a particle gaze trail, so this is a moving particle emitter. This seemed preferred over other visualizations we tried, like arrows and heat maps and discs or markers at the gaze point. However, if you look at this picture, you can see things are getting a bit cluttered when there are 5 students there at a time. And if a teacher is lecturing or a guide is supervising a large group of students, this could get very cluttered. And if you have all these moving around, it has limited usability or usefulness. So what we want to do, instead of showing all the gaze trails from all the students, is we want to filter out the ones that do not appear to be distracted, and just show what's going on when there's a problem. So along those lines, we've also worked on a classifier that tries to identify the distraction level of the student based on eye tracking data, eye tracking features. And so we presented this at the EGVE conference last year. We have been successful classifying 3 levels of distractions. That's low, mid, high distractions. I'll play you a video first to show you the kind of distractions we considered. In this case, it's an audio distraction.
The water vertically flows through the fill media, while the arrows indicate the air flowing horizontally across the falling water. Cold water from the cooling tower is used to condense the refrigerant.
So we had a high accuracy classifying 3 different levels of distraction. However, there are still some limitations. That is, we are classifying overall distractions across a short educational session, rather than doing it in real time. And additionally, the training, when the training takes place on a different environment or different activity than the subsequent detection, then the success rate is somewhat more modest. So we're trying to extend this classifier that we developed to work in real time and to be more generalizable. Now we can try to classify other besides the distraction, besides eye tracking, we can try to incorporate other sensors or classify other cognitive states like engagement levels, or to detect if there's some unusual stress going on, for example, using heart rate sensors or EEGs. And usually to train the machine learning system, so this is a very high level overview. You have some emotion elicitation task, or you have some task that elicits the response you're trying to learn to detect, and then you do the feature engineering, and then you train the machine learning system. So we have worked on some VR emotion elicitation tasks. That is, these are different tasks that resemble some training activities, some skills training activities, but one is intended to be boring, and one is intended to be frustrating, and one is intended to be confusing, and another relaxing. And we proposed these in the emotion elicitation workshop at ACM Chi last year. So I'll show you one of these tasks so that you can understand it more clearly. This is a box sorting task, where a user must pick up these objects from a conveyor belt and sort them into the correct box. And the system, this is in order to try to confuse the user, so we can learn how to detect confusion. The system sometimes incorrectly, on purpose, but incorrectly buzzes at the user as though they have made an error. So I'll play the clip here. So the intent here was that the user would sometimes be confused, because according to the rules of the game, that they understood they were doing it correctly, but the system told them otherwise. And then we try to validate these tasks by using this kind of rating system, where they rate the valence, that is negative or positivity, of their emotion, and then their arousal level on these items, where they rate from 1 to 9 using these pictures. And then we have this emotion wheel, where they tell us what they experienced. This is based on a circumplex model of emotions. So there are different versions of this. And what we found with that box sorting task that I showed you. So we had a small study. It was a small number of participants to try to validate these tasks. And they tended to be frustrated rather than confused. So it's understandable if you watch the video, if the system is being unfair, you may get frustrated. So frustrated and confused are in the same quadrant of this arousal valence plane. So they're next to each other on this wheel. So we're not that far off, but so then the idea is to use this data that we gather during these experiments from these various tasks to train a machine learning system to try to detect problems when people are in VR training systems and they experience some confusion or boredom or other problems. We want to detect that. Okay, now going back to networked VR and teacher interfaces. at the last everyday VR workshop, so last year we presented our work on designing an interface that would inform the teacher when there is some kind of problem detected with a student, or just give the teacher a better overview of what's going on with students. So a teacher in one of these systems like hubs might have difficulty monitoring all the students because they can spread around a large area and some of them fly up into the air, so not all of them are seen at the same time. So one thing we tried was these hovering indicators above a student that would, they had some level indicator here that would inform the teacher how critical the student was. For example, the student raises a hand and there's some level there of urgency in responding to the student, or if there's a network disconnection, or if a classifier detects some kind of problem, then this would increase. And then we also did something that's like a taskbar that is in a small space at the bottom of the teacher's field of view. We have face icons that represent all the students. And then when something urgent is going on, like in this case, a student raising the hand, a tether appears to the student so the teacher can quickly identify where the student is and what's going on and can communicate with that student. So I'll show you a video of this. The video basically shows that the taskbar moves around to maintain position in the teacher's field of view. The students here are also partially transparent when they are when everything's good, when they don't require any special attention from the teacher. So we did here, and what we reported last year was that we did a small study to gather feedback about which kind of presentation was preferred, or which kind of organization of information was preferred, and to test various interface design options. And so this central type of indicator here, this taskbar type of indicator, seems preferred over these floating indicators that are located directly where students are. And there's some other features here, like there are small arrows pointing to where the students are. So we evaluated different ways of visualizing that. All right, and at this year's IEEE VR conference, we are showing another kind of teacher interface. This is a type of cross-reality desktop interface, and what I mean by cross-reality in this case is that this is again an interface where the teacher is not immersed, but the students are immersed in headsets. And the motivation here is that based on our hub study, we don't expect that everyone will want to use headsets. Some of them will get uncomfortable. A teacher may get fatigued using the headset over a long period of time. So we want to improve the experience for immersed students when the teacher is at a desktop. And I'll show you a video in a moment, but there are additional sensors augmenting the desktop, like there's a leap motion sensor here. There's an eye tracking bar under the monitor, and the teacher's actions are mapped to an avatar, and the goal was to try to make the avatar more lively or more human-like, so that immersed users still get some sense that there's a person there in VR with them. The teacher's desktop experience, we wanted it to be somewhat like giving a PowerPoint presentation, so they don't have to worry about navigation or facing different students. So they mainly see their presentation slides, and they can cycle through their presentation slides. They see their avatar here, so they get some understanding of what the avatar is doing. So instead of something like a video, like I see myself on Zoom now, they see their avatar. And the students are represented up here in a row, and when the teacher gazes at the student, the avatar will look at the corresponding student in the VR environment. So I will show you, so this will be presented, I think, in the last paper session on advanced UI this year in a few days, and I will show you the teaser video that the student made for this presentation.
Hi, my name's Jason, and I'll be talking about our work on redirecting desktop input to animate cross-reality avatars. Through this work, we're allowing desktop users of VR-embedded environments to have more expressive avatars by redirecting motions such as eye gaze and pointing motion through desktop input. For example, this avatar is being driven by this desktop interface with an added eye tracker and hand tracker. We validate these approaches with a two-phase user study. We hope that you will come to see our presentation.
So what he's going to tell you in the presentation is that we compared this to using a conventional desktop interface, which is the kind of interface that you see in hubs or Verbella, and using and also compared it to using a teacher using a headset and controllers, and also using another version of this interface that does not have the extra sensors, that just redirects mouse motion so that the teacher can control the avatar based on where the mouse is moving on the screen. And the main result is, first of all, it does show that with a desktop-based teacher, so this is focused on the student experience. We're evaluating the student experience at this point. We haven't evaluated the teacher's experience. So the results are that the fully tracked VR avatar is better than a conventional desktop avatar, and that our approach falls somewhere in between, and that even without the extra sensors, some of the redirection we do, for example, of mouse motion, appears better than what you get with the conventional desktop interface. So you can watch the talk in the advanced UI session for the details. All right. Finally, I want to reflect back on what I think are based on these experiences with hubs and with the Crosshair VR system and doing remote VR presentations. I want to reflect back on what I think are sort of the main challenges or areas of improvement for the long-term success of everyday remote VR for education. So there were a lot of technical glitches causing problems in the hub study. And you also find these kinds of problems being reported in non-VR studies of remote education. So this is not unique to VR. These seem like things that would go away over time. On the other hand, we still find problems with Skype or Zoom. So some users will probably continue to have problems for a long time. Headset comfort was a problem in the hub study. So maybe the current devices aren't quite there yet. However, the sessions were pretty long there. So maybe for short sessions, the current headsets are okay. For longer sessions, some users are probably going to continue to experience problems for some time until there are more ergonomic improvements for headsets. We want to make sure to support users who don't use headsets, either because they don't want to or because they can't. Maybe, for example, they have an impairment. So currently, most of these tools like hubs and Verbella, they let you interact on the desktop just fine. So it's important to retain that ability. Ease of startup is a big problem. So teachers don't have time to do this kind of setup of equipment or to create accounts in their classrooms. So they either need some support from other people. Some of our students could not get the headsets working in the hub study in the first week. So there are still some practical problems getting set up. So you either need some support staff or you need some very simple plug and play type of device where you don't have to do anything. You just put it on. And easy content generation. Also teachers, when they're creating lessons, I think their limit is often doing something like a PowerPoint presentation. If creating a lesson is any more complicated than creating a PowerPoint, I think most of them won't invest the time yet. However, if the technology becomes more common and more proven, then they may invest more time. But to have good content libraries or easy content generation, like quickly scanning in real objects, this might help. In real lectures, teachers can generate content very quickly just by writing on a board. They can just on the fly generate sketches to respond to student questions or to add detail. So it would be very nice if there's better writing support in VR for something like a whiteboard that or other or even it could even be some easy creation of 3D models to illustrate what's going on, to augment the lecture and respond to questions on the fly rather than just using pre-made models or pre-made lecture content. Large-scale delivery and portability, this refers to supporting different devices and different levels of performance on computers. So this is I think this is one of the motivations people have for using Mozilla Hubs recently, is that it runs on many devices and many different kinds of VR displays. However, it's not very feature rich, so there's some compromise made there. Privacy and security when tracking students. So the more data we gather from sensors, the more we have to worry about informing people of what exactly is going on and letting them decide if they want to opt in or not, and securing the data or erasing the data. But it seems based on our hub studies that students would prefer to have their, at least their basic motion tracking data communicated than their video streams. And then understanding the long-term effects on students, especially if they are very young, especially if they have long exposure to VR, there's some evidence that VR may negatively impact their motor development or cause false memories. And we don't understand also what happens when VR is heavily integrated into a curriculum to present a lot of topics. So that's something that needs to be figured out. So, all right. So thank you all for your attention. And I want to thank my collaborators or contributors here who provided the video clips and images, and also most of them are students who did a lot of the dirty work here for the studies. So Arun Kulshresh is my co-author for this book chapter that we submitted that summarizes all of these items, and the others are lab assistants who have actually carried out the work. Thank you.
Okay, thank you, Chris, for the very interesting presentation. I see that there are a lot of links between the research that I've also done and yours, especially with the cross-reality application, which is very fascinating. So if in the audience there's anybody who wants to ask a question, please write it in the chat. But in the meantime, that we kickstart a Q&A, I wanted to ask you a few questions. So in your presentations, and also in some of the research that I've seen on this team, is that these works mostly focus on the lecturing aspect, no? On giving a presentation and so. And I was wondering if you had also thought about other aspects of a course. Now, if we imagine that in the near future, such VR or blended reality courses will be a thing. So there are also other aspects, no, that we as instructors or educators should focus on. For example, like an exam. No, I can imagine that VR without a lot of changes would be good for having some kind of like an oral exam. No, I don't know if you still do those at your university, but what about like a written exam? No? Imagine that we have all people in a VR environment and they need to perform some kind of test. No? What kind of activities or formal exam would lend themselves to VR, if at all?
Yeah, at the moment, it would be a different, I think to justify VR, it would be a different kind of exam probably than we give now. Maybe, if you have exams where people have to point to models and demonstrate their knowledge of anatomy or demonstrate that they can perform some skill, this makes sense. If it's a written exam to answer questions, at the moment, I don't think I would promote VR for that. And also, until the pandemic, I didn't think VR would be a good medium for lectures or presentations. You know, I thought of it as an environment where you want 3D content and you want a lot of interaction. Maybe you want some self-paced learning, but hearing about Zoom fatigue and possible factors of Zoom fatigue, it might be that VR is even promising for lectures. So yeah, other activities, yeah, self-paced exercises and 3D content and 3D interaction. I think that's where VR, that's what I thought was the strength of VR prior to the pandemic. And now also for meetings and lecturing, it might have some advantages to Zoom.
Yeah, indeed. So, yeah, yeah. Thanks for the answer. Another question I had was about something you touched on in one of your last slides. Now, you said like in a real lecture, teachers can use a pen to draw on the whiteboard or blackboard, not something very quickly. But in VR, that's not so easy. And also something that which relates to the everyday aspect of the workshop is that most of these works come from the VR community. So because we know the tools, and it's, I think, easier to us to develop content for it. But what about people that don't come from a technical background? Even though the barrier, I think, has been much lowered. Saying to other people from other fields that they have to use Unity or Unreal or even to develop something custom for Mozilla might be daunting. So I was wondering what we could do. The idea would be to have maybe some kind of PowerPoint for VR, to spread it to the masses. But what can we do more in order to diminish the technical gap? What do you think?
Yes, there should be some authoring. There should be some authoring system that's sort of as easy as PowerPoint. And I think there is some commercial interest in doing this. So for example, at our university, we have a tool from Eon Reality called Eon XR, and people can load models into it, and then they can attach labels very easily to models, and then they can create activities where students have to go through sequences of tasks like identifying a component or answering a question. And these can be delivered on various devices, so they don't have to use headsets for this. But the point is to make this easy enough so teachers will adopt it. But yeah, it's also it's also a question about what subject is it good for. Some abstract things I think will be very difficult to author or learn in VR.
I think it's also a question of resources. I think it will make sense even for like subjects in the humanities. I always thought maybe we can use VR to show the reenactment of a famous battle, or even to walk the classroom to view like scenes from the life of a poet or writer to understand the content. I think that would be a lot more immersive, of course, than reading the text in a classroom book. But that, in order to make it compelling, it requires a lot of resources, of time and modeling, the narrative. It's almost like writing a video game,
Right. Yeah, it requires some investment and some special kind of skills from the modelers or artists.
Yeah, well, but maybe at some point. I mean, even like a few years ago, this seemed to be the far future, and now it's here. So maybe the wait will not be so long. We will be surprised in the near future. Okay, so those were some questions from me. Maybe there's other members in the audience that want to ask some questions, or from my co-organizers.
Yeah, I had one. It was a very specific one. I just posted into the chat. That is about your work on using AI for identifying emotions in interaction with the VR or virtual environment. And you talk about that you measure actually frustration and not confusion. And I was simply wondering whether the confusion could be caused frustration, so that actually the confusion that is probably a little bit more subtle than the actual like perceived frustration. Do you think that this might be something that can cause, because what people are just subjectively experience is frustration because it's not working like they expect it to be, but confusion could be still an element of this.
Yes, I think they are definitely related. So, you know, it makes sense. If you're confused, you in a lecture or in a task, you would become frustrated. So at the moment, I'm not sure how to separate them. There are some elicitation tasks that try to confuse people by giving them difficult descriptions or incomplete or confusing descriptions on purpose. And now I'm wondering if those also would cause frustration. But there is prior work on this that we could look at.
Okay, thank you, Benjamin. Are there any more questions?
Hi, Chris. Thanks for the nice talk. I just posted my question via Discord, but maybe it's easy if I just pick up the question. In one of the experiments, you reported that, in fact, students prefer mixed mode. Why? Do you have explanation? Is it because of the technical issues, the content, or what is the reason that the students still prefer mixed mode of systems?
So my guess is, and this is from my own experience, if you have a reasonable desktop interface, then you're not as motivated to put on the headset all the time. And so maybe if you want to pay attention to other things going around you, or if you just want to be comfortable or very efficient, then you would prefer not to use the headset. And I recall, there was a study of the IEEE VR 2020 conference and their use of different tools. And they reported that people wanted to use the headsets less and less as time went on. And they did not like the headsets as much during lecturing as they did during social events. So it may also be a matter of what is going on in the virtual environment at the time. But I think my own experience is that I don't think I would like wearing the headset all the time either if I have a good desktop alternative.
So is it still technicality or really about interactivity and taking control over social and other aspects, seems?
I think it's a mix. Some of it is comfort. It's just very comfortable to sit down at a desk without wearing anything on the head. So if the devices become more sort of transparent and the quality and ergonomics improve, I think they will be more accepted. I think some of it is that some of the tools are missing in VR. If you want to take notes or type, you can do that currently with a desktop more easily than in VR. So I think as the technology improves, both in terms of the software and the hardware, I think headsets will be more accepted or more preferred.
A lot of avenues to go ahead for all of us to develop. Really nice. Thank you.
Okay. Any more questions?
The chat.
Yeah, from Matthew. Do you want to ask your question yourself, or should I just read it? Oh, yeah. Thank you.
Sure, I can ask it. So in the situation where you have you have a classroom with users where some of them are using VR and some of them are not. From the videos, it looked pretty obvious, like which users were in VR and which weren't, like because the headset was always tracking the ones that are using VR, so you can see their minute movements more. I was wondering if you think instructors or other people in the classroom think of those kinds of students differently, like if they think that because the users wearing VR are moving more, if they appear more like present or engaged to the instructor, to their peers, compared to the ones that are using desktop.
Yeah, interesting question. You know, from using Mozilla Hubs, I guess I would maybe. Okay, I'll approach this from a different angle. We did this in the other direction in this work that's being presented this year at IEEE VR here. We looked at how students gaze at different instructor avatars, and when the instructor had a sort of more lively avatar that had enhanced sensing rather than a standard desktop, then the subjects gazed at the instructor's face more. So I expect that it would also be true in the other direction. The instructor may gaze at those students more who are using VR because the motions may draw their attention. So it would depend on the instructor's personality if that also manifests itself in some different treatment. Another comment I can make is it's very obvious when the students sort of put the headset down and walk away, and that creates a bad impression. If they do it a lot, if they walk away briefly, it's understandable. There may be something going on. But if they are using tracked VR and then their avatar is still, and it could be a network problem, but it could create the impression that the student has just checked out and is just pretending to be there.
Sure. That's interesting. Thank you.
All right. Well, if there are no more questions, then I would thank Chris again from behalf of all the organizers and the audience. Yeah, so thank you, Chris, for dedicating your time to us in the workshop. Yeah, so we are now on a 15 minutes break. So the workshop will resume at well, here it's half past midnight. So I think, yeah, that will be probably half past noon in New Zealand. Yeah. Okay, so we'll get back here in about 15 minutes. All right. Well, thank you.
Thanks for having me at the workshop.
Yeah, thank you again. Svetlana, Benny, are you still there? Yeah, I can't hear you. Well, yeah, I just wanted to ask you what's the plan for later.
I don't know whether Daniel is here and Yongkang. I would suggest that they run the videos like the previous year. So Daniel runs his video, then Yongkang, then I run the videos. And in the meantime, I post this message, not the message.
But yeah, I mean, last time all the videos were like centralized. I think one of us was just playing the video. So you want the authors to play the video themselves? Because
Probably. Probably.
Yeah. So if that's the plan,
because we have only 4 of us, so it will be easier. And if they run their own videos, and then to.
Yeah, I'm sorry if I haven't been present for the workshop mostly, but yeah.
Could you see the link, whether the link works to edit the questions? And like the previous time, we just go in a round discussion at the end, so everyone could participate more vividly and interactive. Does the link work?
Yeah, I've seen, but I mean, I think it. Yeah, so you were supposing to paste the questions that are asked in this.
Yeah, because we could return always towards these questions, or you prefer that we run 10 minutes?
I mean, I think it would be up to the person, like the host, not to have at least one question. In the meantime, that there are some more questions for the audience. And speaking of which, who is going to present the second part? Because I see that you are listed on 2 papers. Are you going to present 2 papers, or is one of your?
Yeah, I record it because it's already midnight in Liverpool, so I record it and I will run the videos, but I'm still here, so open for questions.
It will be best if somebody else introduced you. I think no, you can't introduce yourself. So like Benny, do you want to do it, or?
Yeah, sure, I can do it.
Okay. I mean, the other question, I don't know, since we are here, is, I mean, I don't know why this year hasn't had a lot of submissions. So just 4 doesn't look too promising for the future. But so what do you think? Should we keep going?
I think because of the timing.
Yeah, probably the fact
it was really very short over New Year, and then 10th of January, and people mentioned that there was a kind of another conference with a similar deadline, something like
Kai, probably. I didn't. I think the other workshop too need it. I don't know if it's happening at the same time, so not. I remember
the same. If you look on all workshops, it's the same story.
Yeah,
so,
but do you know if the overall conference has had less submissions, or because maybe a lot of people were expecting to have to travel to New Zealand and maybe they didn't want to do it.
No, I think it was quite similar to last year as far as I remember. Yeah. So for conference paper especially, it's
okay.
So there was no specific decrease, but I think the timeline for workshops was very tough this time, even tougher than last year's.
Yeah,
that might be an aspect. Okay. Yes.
Anyway, there's still the book to sort out. I don't know if you have noticed, but I started writing something in the overleaf chapter. So did any of you had the chance to look at it?
Not yet, but I will finish my chapter very soon.
I also sent the other one from our group. Is it under review? Because I haven't seen it.
I think Svetlana and I will look into it, and the third person.
Yeah, I've seen your questions, Benny. Sorry, I was going to answer after all this workshop. But after 20th March, I'm available because I have another conference deadline 20 March to submit. And after that, I could do revision, whatever you want me to do.
I think we should try to finish until the end of March.
I do it 10 days from 20 till 30. I have dedicated.
You mean the editor chapter? Okay, that might be. tough, but because I mean I started writing, but I suspect we
no,
have to.
I mean reviewing and finishing the content
all right.
chapters, the content
Okay.
chapters. So I hope that we will be able to submit the chapter until end of next week or so.
Yeah, maybe I can send you like an outline of how I imagine this editor chapter to look like, and then
we need to fill that up.
Also, the other chapter that I've sent you on PDF has to be, but really after 20th March. As soon as I submit the other paper for the other conference, then I give you a sign. Okay, I'm available.
Excellent.
Just send the task, and I will do in meantime.
Yeah,
but after 20th March, you could still send it, but I will do it after 20th of March.
Sounds good to me too. Mm-hmm.
Yeah. Okay. Yeah. So my idea for the chapter was to do like, like we talked about in the beginning, like a manifesto of everyday VR, like what is the definition, what other works have been done at the workshop and in other conferences. And
I think that's also something that makes a lot of sense if you start this.
Yeah. In fact, that's
because you're the part of the whole thing, right?
Anyway, I'll get back on it because I was doing the video for Kai. And speaking of which, is any of you going or planning to go to Kai?
I'm not sure yet. Do you plan to go there physically?
I hope. If they let us go, I will. It remains to be seen, like what's the situation in May, because we submitted a paper. It was a long process, and I want to be there to present it.
Congrats. Sounds good. It's for me. So my second daughter was born in the end of January, so we are a little struggling.
I can imagine. Yeah.
How is she doing? Can your wife also well?
Yes, both are well. Yeah. So we had some issues from the beginning, but nothing turned out to be negative, so it's all fine.
Nice to hear.
Could you take also paternity leave? How is in Germany organized?
I could do, yes.
Okay. But you are busy with the conference.
Yeah. It's quite late, but that's how it is, right?
You look a little bit tired, so I can imagine what's going on.
We also decided to move, so it was
all together. Wow.
So it was a little bit like it was not only our own choice, but we bought a house here it's the situation on the market for houses is like you have to take it and then to move, or you cannot do it, and so this is a lot of stuff together. I don't know.
In Leuven, it's also an item. We also bought a house. I can't imagine how much it is. I read the house price in Germany even worse. Maybe. Where is it in Trier? No, maybe.
Yes. Yeah.
It's not as bad as Munich or something like
that. No, but it's the issue is that Luxembourg is very close, so it's very, very close. So you can earn much more money in Luxembourg and live much cheaper in Germany. So it's a little bit similar to the southern area around Switzerland. Konstanz, for instance, is a city right next to the Bodensee. Area where you can live quite cheap and earn a lot of money in Switzerland. And this is an issue because that is not good for the house
increases the prices. It's the same around the Brussels. All the people gravitating to the EU and cannot afford Brussels. Move a bit outwards.
But we were quite lucky, I would say. So we got a nice house for a reasonable price. It's still expensive, right? If you look from 10 years on a 10 years perspective, but
Yeah, let's hope there's no crush, like housing crush in the next
Yeah,
year.
I don't know.
Okay.
It's crazy times, so everything can happen.
Mm. Oh yeah, of course. Yeah.
Yeah. By the way, so coming back to Kai, I'm not sure yet. Might be. So
Yeah, let me know if you're there. Like,
yes, of course, I will let you know. Mhm.
You didn't go to WIS, no, because the WIS 19, no, that was also in your links. That was also my last physical conference. And so
Oh yeah.
it's all back to the.
I think my last was VR 2019 in Osaka.
Okay, yeah, that was good. Yeah.
So the last
I wasn't there.
big one.
Yeah.
Yeah, the last bigger conference, international. Yeah.
In the world of yesterday.
So I plan to go to New Zealand. I was highly motivated.
Yeah, me too. I thought, okay, maybe I will do it like once in my life and go to New Zealand now or never. So.
Yeah, I've been there. So.
Oh, you've been already. Okay.
I have still an option to go there. I think 1 or 2 years again, I guess.
Like a sabbatical or.
Yeah, exactly. So I have a nice contact to University of Waikato in Hamilton, Northern Ireland. And I went there some years ago and did some teaching and had their free living. That was excellent. And they were also shipping me there, so that was great. Yeah.
It's a nice place.
Yes, absolutely.
So I really have to go.
Okay.
Just for 1 minute, and then I'll be
Sure.
back. We start at 1:30.
Yeah, and just a few minutes, I think, no? 3 minutes.
Yeah, just a little bit to
also
relax.
try to get something to drink.
Yeah,
I guess I should.
I just had coffee, but I need more to refresh, and then I see you at actually 2 minutes, 3 minutes.
Yeah, I'll come back as well.
In a few minutes. Okay, thank you.
In a bit.
Hi, Daniel.
Hello. So right now, screen sharing is disabled.
Could you try? Because I
Yes,
think
I
it's
just disabled.
Okay.
Is it?
Mhm.
I keep getting a message that says host disabled participant screen
Okay,
sharing.
one moment. I
but-
think maybe I just need to make you like a co-host.
It's
Yeah.
okay.
Try it now.
It works.
All right, great. So would you like me to stop so you can show your slides for just a second? Or
Young
No,
Kang.
I think we can start. Or if you want to, Svetlana, if you want to introduce him.
Probably, yeah, just to give an overview, and then also Young Kang. I don't know whether Young Kang is here, so to be sure that it's fine, or we just start.
in this presentation, we will be sorry, you want me to begin?
Okay, let's start, and welcome back after the break to our nice workshop. We had a really fantastic talk by Christoph Borth about virtual reality and education, so quite a lot food for thoughts. And now we go ahead with the papers. We start with Daniel Uburn, presenting comparing teleportation methods for travel in everyday virtual reality. And perhaps, Daniel, you could start when you are ready.
In this presentation, we will be discussing our project, Comparing Teleportation Methods for Travel in Everyday Virtual Reality. My name is Dan Clyburn, and I'll be presenting on behalf of my co-authors, Dominic Lasaka, Henry Chung, and Tapaswani Jenna. We are from University of the Pacific, located in the Central Valley region of California. Travel through virtual environments is one of the most common user tasks in everyday virtual reality applications. Unfortunately, traditional travel techniques used in video games, such as moving a joystick or pressing on a thumbstick to change the user's vantage point, can cause users significant discomfort in VR. However, when teleportation is used to support user travel in everyday VR applications, users tend to report higher levels of comfort. Many implementations of teleportation in VR applications have been reported in the literature, and we describe just a few here. For example, a jumper metaphor has been implemented that allows users to reach faraway locations in a virtual environment when real walking is the primary locomotion technique. A point and teleport technique has been defined that relies on hand tracking or a controller to select a destination for teleportation. Finally, an out-of-body locomotion technique has been described that is similar to teleportation. With this technique, the vantage point of the user is moved away from their avatar representation. The user's avatar is then moved to a new location, and then finally the vantage point of the user is returned to the position and orientation of the avatar. While substantial research has been performed comparing teleportation methods to other methods of user travel in virtual reality, relatively little research has been conducted to compare multiple implementations of teleportation for the same travel task. One notable exception is the work of Schaefer and others who compared teleportation methods that track one or both hands. In the remainder of this presentation, we describe an experiment to compare 4 teleportation methods that can be implemented in everyday VR applications using standard VR controllers, such as the Oculus Touch controllers shown in the image on the lower right. We call the first teleportation method the arc method. With this method, an arc appears from the user's hand to the floor when a button on the controller is pressed. By using the thumbstick on the controller, users can control the direction they face at the conclusion of the teleport by changing the direction of this arrow. We call the next teleportation method the head pointer method. With this method, an arc appears from the user's head to the floor when a button on the controller is pressed. Like the arc method, by using the thumbstick on the controller, users can control the direction they face at the conclusion of the teleport by changing the direction of this arrow. We call the next teleportation method the hand selection method. With this method, users choose one of the yellow circles located on the ground in the virtual environment to which they would like to teleport by pointing to it with their hand. Users then teleport from their current location to the center of the selected circle. Like the previous methods, by using the thumbstick on the controller, users can control the direction they face at the conclusion of the teleport by changing the direction of this arrow. We call the final teleportation method the step method. With this method, users simply press a button on the controller to teleport one virtual step forward in the direction they face. As with all the teleportation methods implemented for our experiment, users can turn their head or their entire body to change the direction they face in the virtual environment. We first developed the step method in the context of a virtual heritage application shown in the images on this slide. We wanted a teleportation technique that would feel more natural to users and more like real walking than the other teleportation methods in our study. Subjects experienced all 4 teleportation methods as part of our experiment. For each method, subjects first visited the training environment shown at the top of the image to the right. The purpose of the training environment was to help familiarize subjects with the teleportation method and travel task. Subjects then visited 4 times the test environment shown at the bottom of the image to the right. In each environment, subjects began on the right of the virtual hallway. They were instructed to travel as quickly as possible to the end of the hallway as indicated by the positions of the green circles. Time and distance traveled were recorded for each visit to the test environment. It should be noted that data recording did not start until subjects passed over the black line on the floor of the test environment. This was to ensure that subjects were fully prepared to travel to the end of the hallway before data recording began. 18 subjects participated in our experiment, which included 16 males and 2 females. The mean age of subjects was 26.1 years old. All subjects were required to have access to their own Oculus Quest, which they could bring to their testing session. Subjects connected their Quest to the researcher's computer through an Oculus Link cable when they arrived for their session. This procedure was approved by the Institutional Review Board at our university. Separate repeated measures ANOVAs were conducted for the 2 dependent variables of time and distance traveled, with trial number as a within-subject variable and teleportation method as a between-subject variable. With respect to the time variable, there was a main effective trial number. Post-hoc comparisons revealed that mean times significantly improved from trials 1 to 2 and then from trials 2 to 3, but subjects were not likely to significantly improve their times from trials 3 to 4. There was also a main effective teleportation method. Post-hoc tests revealed that subjects were significantly faster with the arc and hand selection methods than with the head pointer and step methods. With respect to the distance traveled variable, there was a main effective teleportation method. Post-hoc comparisons revealed that subjects completed the task traveling significantly more distance using the hand selection method than any other method. Subjects completed the task traveling significantly less distance using the step method than any other method. At the conclusion of the trials, subjects were asked to rank the methods in order of preference for traveling to the end of the virtual environment as quickly as possible, for comfort, and for general use. A chi-square goodness of fit test was conducted for each variable. For traveling to the end of the virtual environment as quickly as possible, henceforth referred to as quickness, subjects indicated a significant preference for the arc and hand selection methods. For general use, subjects indicated a significant preference for the arc method. No significant preference was found for comfort. Subject opinions were aligned with experimental results with regard to traveling as quickly as possible to the end of the virtual hallway. Subjects preferred the arc and hand selection methods for quickness and were significantly faster with these methods. The arc method was significantly preferred by subjects for general use. Subjects commented that the arc method was easy to get used to and more effective. However, all of our subjects were experienced VR users. In our opinion, the arc method is the most prevalent teleportation method employed in VR applications today, so our subjects likely had the most prior experience with this method. Interestingly, not a single subject chose the hand selection method as the preferred teleportation method for general use, even though this method allowed for fast completion of the travel task. One subject explained that hand selection would feel too restrictive in where I could go. Subjects traveled significantly less distance through the virtual environment with the STEP method. One subject wrote, "The advantage of STEP is that I can travel to specific locations with motion similar to natural movements without feeling sick. With the STEP method, subjects likely took travel paths in our virtual environment, most like the paths they would have taken if they had run through a similar real-world environment." However, another subject stated, "STEP would take too long if I needed to go far. It may be that the STEP method supports more natural movement, and it encourages more efficient travel paths than the other methods, but at the expense of longer travel times." These results suggest that the best or optimal teleportation method may depend on the actual travel task. The hand selection method may be useful for travel tasks that require traveling long distances quickly in virtual environments. However, for maneuvering tasks that require smaller, more precise movements, such as examining objects in a small virtual space, the STEP method may be helpful as it's most like real-world movement. For general travel tasks in everyday VR applications, such as VR games and virtual learning environments, the ARC method may be preferable. There are some important limitations to our study that should be mentioned. First, due in large part to the difficulty of finding subjects that had access to their own Oculus Quest, we had a relatively small number of subjects participate in our study. Furthermore, since the subjects had access to their own Quest, they were all experienced VR users. Thus, the opinions of our subjects may only be reflective of experienced VR users. It may be that novice VR users prefer different methods for teleportation and would perform differently on our travel task. Future work should include more subjects with less previous VR experience. Our travel task was also relatively easy for subjects to complete. They were only asked to travel in one direction in the environment. When subjects became disoriented, it was only for very briefly, since we had placed arrows on the floor pointing in the direction that users should go. Our subjects were able to quickly determine the correct direction to move by referencing these arrows. Future work should include comparing teleportation methods for more complex wayfinding tasks, possibly such as naive searches of large virtual spaces for locations of interest, or exploring unfamiliar virtual environments with limited navigation assistance. Here are the citations for the references we mentioned in this presentation. Thank you for listening.
Thanks, Daniel, for the talk. I don't know whether all participants understood that at the time of the presentations, people could write the questions on the link I just shared. So in such a way, we go in around the discussion, and maybe in meantime, people are inspired with more questions about a particular talk. But if anyone has a burning question at the moment, could ask Daniel. At the same time, I would invite Yongkang to prepare his presentation. Yongkang, are you here?
Yes, I'm here.
You could start preparing your presentation. In the meantime, we could use...
yes, can you play my recording video?
You could play it as well.
Okay, so wait a minute, I need to open it.
Yeah, it will be easier. Anyone has a question at the moment for Daniel?
Do you want to ask the questions all together at the end or after?
Yes, I would like to ask at the end. That's why I posted the link so people could write the questions, and then we make the discussion. But because we are waiting for Yongkang to start his video, then we could use the time for some burning questions at the moment. So it's also fine since we are only 4 of us.
Yeah, there is one in the document, but maybe you can wait at the end.
Would you like me to just respond to it?
Yeah, while you are there, maybe we can.
So the questions on whether or not teleportation negatively influences orientation, I think I'm summarizing it really closely. And I do think that's the case. And so I think one of the most interesting results here was that the STEP method, people actually traveled shorter distances because I suspect it was more like real world movement. And so I have thought about, as possibly a follow-up study, creating a more complex environment that people have to search and find target locations of interest, and then have them do that multiple times. So obviously, if they learn the environment well, they'll be faster at it. I'm wondering if some of the teleportation methods, that while they allow you to move quickly and complete the task quickly, maybe if it doesn't help you build quite as effective of a cognitive map of the environment. So something like, stepping through the environment where you're moving slower but more, close to natural movement, if that would help you do a more effective job, I guess, of learning the actual environment. That was my thought on the issue, and I'd be happy to hear other people's thoughts or comments on that as well.
Any comment to Daniel so far? Maybe we could leave people reflecting on the response from Daniel and still write the questions in the document. In the meantime, when Yong Kang is ready, maybe we could invite him to start playing. You should share the sound.
Can you see my screen?
Yeah, but
see the
you have
screen,
your
we could not
audio
hear.
disabled.
Okay, so let's start then.
In the video, in the YouTube video, the volume.
Yeah,
Yes.
sorry.
We cannot really hear anything.
Can you hear anything?
No.
It sounds like you're transmitting the microphone feed of the video, but not the audio track itself.
When you share your screen, you have to click the options to share your computer audio in the sharing screen in Zoom.
Okay, wait a minute.
You have to return back and start sharing also the sound.
Wait a minute. I need to do it.
Well, if this is going to take time, maybe we can move ahead.
We could play then. Yeah.
No, we can move ahead with your next video, and then Yong Kang can
I could
return later.
Could try.
Can you hear the voice? Greeting for everyone. My name is Yong.
Yes, we can hear it. We can hear it.
Yes. Okay. Thank you. So I start play it. Can't see. Greeting for everyone. My name is Yong Kansin, and I'm from Guangdong University of Finance. My research topic is with WebXR user interface study in designing 3D layout framework in static websites. The first content is about the research problem. At first, we provide two images. The left image is the HoloLens platform, and the right image is the VR platform. We find that XR devices still have limited support to transfer websites into XR platform. As you see, both of the images, they supporting the basic visual effect, the same as the desktop version. However, they only support a very simple gesture, and the user interface didn't use the XR characteristic. Therefore, we raise up a question. What about design an efficient and immersive interactive framework in WebXR is necessary? That is our motivation. However, website has many types. We need to narrow down the specific levels research scope in the first stage. So in the first stage, we plan to build at the initial design principle with fundamental XR characteristics in static websites. And the static website should be built by HTML5. The second part is the framework overview. In this section, we'll talk about the design concept, main content, and the navigation system. At first, we talk about our design concept. At first, we need to divide the different user interface layout by different platforms. As you see in the figure, we divide into XR platform, mobile platform, and desktop platform. We use the responsive layout to do it. Responsive layout is not a fresh technology. It already happened in the mobile platforms in 2010. And then at that time, responsive layout is used to divide the mobile platform and desktop platform. Therefore, we can use the responsive layout this technology to divide the 3 different platforms. The second section is about the 3D layout. We need to build a 3D layout. So we need to divide the website section in each page. Header, this is navigation. The body is the main content and the footer. The footer is about the copyright information. Normally it's not important, so we design it in sitting in the 3D corner, environment corner, so it's not that important. The main content, most important is header and body. The navigation information displays a 3D perspective to guide the user to explore the website. The body section, the main content, divides the content into different blocks. Different blocks display in different positions in the 3D environment. Then we move to the main content. Here is the main content layout plan. The main content is in the middle, and the right side is in the scroll bar, and the left side is the navigation icon. We discussed about the main content, how it looks like. At first, we already in the previous slide talking about the content divided into different blocks. So the current block is in here. And the next block and the previous block is up and down. When the user scrolling, use the gesture, and then different blocks will be moved from the different sequence by the sequence. Here is how the scroll bar looks like. When the user uses the gesture to click in here, they will be moved to next or the previous section, and then it will show a small screenshot for each page, so the user will know exactly where he is, and he also can know the overview of the image, the page. And then we design the prototype by Unreal Engine. So here is the VR platform, as you see how to use the gesture, move up or down, and then use this one to up or down, also the same as this one. And then we also testing in the MR platform here. But the screenshot, because the field of view is quite large, so it looks quite small. But in fact, if you play in the HoloLens, it's not that kind of the small, it's very big, just the image capture problem. So as you see this one. And then we will talk about the navigation. The navigation design working flow is in here. At first, this image already happened in the main content. So we talk about the navigation icon right now. When the user click the navigation icon will be disappear. As you see, the main content, the distance in here is quite different. They will move back, and then the location panel will be displayed in here, and then there will be also have a 3D ring to control the panel. The next image we talk about how the navigation design working flow will looks like. At first, at the previous slide, we already talked about the navigation icon. Click that and then show the location panel. The location panel will show the location path and let the user to know where he is. In the location panel, there will be the same link in the same sub-level. So the users can click the link to display the selected place. At the same time, you can use the 3D ring, use the gesture for rotating the 3D ring to move to the menu panel. Menu panel contains all the levels and sub-levels menu. So where you can scan all the menus in here, and then you can click the selected link you want. And then there will be the panel concept. Here is the location panel. You can see exactly know where the position it is. And then the second one is the menu panel. As you see, you can check all the page, their mental description. So the user can, after read the description, can know the overview about the content that will be more visualized. And then there will be the prototype overview under the VR, as you see how to rotate it and then transfer it. And then there will be the location panel and the menu panel. It's also the same effect by the HoloLens in here. And then we will start, second phase, we will start to display the demo video. The demo video I need to say is because it's running under the desktop and then remote and controlled by the HoloLens. Therefore, there will be some recording quality. Please everyone forgive with that. Thank you. Please remind that the quality, if you use this prototype, is very normal, just the recording problem, just the recording, there will be some image resolution loss. After we discuss about the demo, we will start to talk about the conclusion that will be about what our current research limitation and the future work. And also because the reviewer has some question, we also need to answer that. And the first one is how to prove is it work. We will provide a comparison study between the PC and MR. Right now, I have started to run the user test by the PC. The users can scan the visit the platform, visit the website and answer the question. And then I will start to running the users to run, use the HoloLens to check the website and compare the reading efficiency. And the second phase is the device types of information, because in the website there are many elements such as like the table or the sliding or some input element. There are many things. We need to analyze how to improve the data visualization in XR platform. We will discuss how to make the information in more visualization and more readable in XR platform. That's also we need to do in the next stage. And the first thing is the better represent diverse type of information. As everyone knows, the website does not contain the static website. There will be also include a dynamic website. For the dynamic website, future study will narrow down the specific service scope to design other general framework. So we still have many things to do. Right now, our position research just moved to still in the initial stage. Thank you, everyone. That's all my presentation today. If you have some question, just let me know.
Thanks, Yongkang.
Okay.
Nice presentation. And I still invite the people to write their comments and questions in the Google link I just posted.
Yes, also I can open the Google document and share it.
You could not open?
I can open the Google
Okay.
document. Yeah.
Yeah, okay. Then we come back to the...
Yes, I checked. The first question is which type of the website would be the most for the current framework. Right now, my design is in initial stage. So right now it's normally for company or the university that business introduction website that will be suitable for this framework. But if you say for like some blog or some e-commerce, that's absolutely didn't fit. So if we need to design the e-commerce or some service website, I think it should be at least need to design another framework. Yeah, because the layout or the other things is quite different. The content or other things. So.
Okay. Thank you very much. So if there are any further questions, please feel free to add them to the document. So we will have some time in the end to answer these and also have some deeper discussions. So far, I'm taking over because Svetlana will present the last two talks, the last two paper talks here in this workshop. So the first will be on virtual try-on, how to enhance consumer experience. That's a work she is co-authoring with her colleague, I guess, Chloe Barr. So please, Svetlana, just get the video rolling.
I hope that you could hear well the sound.
I will.
My name is Svetlana Bialkova, and I'm a senior lecturer at the Liverpool John Moores University. I'm presenting today a talk on virtual try-on, how to enhance consumer experience, together with my co-author, Chloe Barr. Why this study? Well, we've seen an uprise on augmented reality application in marketing practices. However, the technology seems to not be always accepted and used by the consumers. Therefore, there is a need to better understand the factors loading on consumer adoption of augmented reality. We further discover inconsistency in literature. To close these gaps, we have to go to provide understanding on factors driving augmented reality experience evaluation and its impact on shopping experience. The main research question we address is which factors determine the satisfaction with the experience. We have discovered that despite the fact that the literature is not univocal on factors driving virtual trial experience, a couple of parameters emerged to be crucial, namely interactivity, realism, ease of use, and immersion. Therefore, we are addressing these parameters hereby. Namely, the interactive technology can stimulate product appearance and functionality. Realism characterized by naturalness and vividness of sensorially rich mediated environments enhance the experience evaluation and therefore is reflecting how consumers like the virtual reality experience. We also know that ease of use, convenient and enjoyable technology may lead to more positive attitudes, and therefore it's very likely that consumers will continue to interact with these technologies in the future. Immersed consumers are engaged, they like the virtual reality experience and will return. Based on these previous theoretical notions, we hypothesize that interactivity, realism, ease of use positively affect satisfaction with the virtual try-on experience. Satisfaction with virtual try-on experience is positively correlated with immersion. We further look at purchase experience itself, thus having a connection between augmented reality experience and the actual purchase behavior. We looked at utilitarian and hedonic aspects, namely utilitarian defined as driven by needs and reasons, and hedonic purchase being emotional, occurring infrequently, and having an action with pleasure. We hypothesized that utilitarian and hedonic values positively affect the purchase intention. Utilitarian and hedonic values affect also the product knowledge. Utilitarian and hedonic values are extensively explored in the marketing literature. Utilitarian values have been connected with information quality, performance-related effectiveness, reflecting the goal-directed benefit, while hedonic benefits have been related to enjoyable experience, aesthetic quality of user experience involving pleasure, are leading to enhanced brand value and purchase intention. Therefore, we hypothesize that the quality of information has a positive relationship with the perceived utilitarian value, and aesthetic quality has a positive relationship with the perceived hedonic value. We tested this hypothesis in an empirical study asking our consumers to try a product and to buy in an imaginary task lipstick. After completing the task, participants had to complete a survey. The survey encompassed the following components. From one side, we look at the virtual try-on experience itself, encompassing constructs, interactivity, immersion, realism, ease of use, and satisfaction, based on classical virtual reality literature, as well as technology acceptance model. Concerning the purchase experience itself, we looked at classical marketing papers, namely exploring constructs aesthetic quality, information quality, utilitarian value, hedonic value, product knowledge, and purchase intention. Items were addressed on 7-point Likert scale, and all scales have been substantiated statistically high Cronbach's alpha bigger than 0.70. So we could rely on our scales and look further at the results. Concerning virtual try-on experience, we found that consumers scoring high satisfaction are actually scoring better in terms of interactivity, realism, ease of use, immersion, and satisfaction. Similarly, concerning the purchase experience, consumers reporting high satisfaction with the virtual try-on experience also reported utilitarian value, information quality, product knowledge, aesthetic quality, hedonic value, and purchase intention to be higher in comparison to consumers in low satisfaction group. Furthermore, to statistics lovers, I have the correlation showing that satisfaction is correlated with interactivity, realism, ease of use, and immersion. Concerning the purchase intention itself, it correlated with utilitarian value, hedonic values, information, and aesthetic quality. Product knowledge also turned to be interplaying with utilitarian, hedonic value, information quality, and aesthetic quality. These data are crucial to substantiate our hypothesis, namely that interactivity, realism, and ease of use positively affected the satisfaction with the virtual try-on experience. This finding is in line with previous studies stating that when individuals interact more easily with the technology system and are involved with the content, they will perceive greater efficacy of control, namely because realism, reflected naturalness, and vividness of sensory-rich mediated environments was recognized as a crucial attribute in consumer perception of augmented reality. Furthermore, satisfaction with the virtual try-on experience was positively correlated with immersion. In the R context, however, Studies on immersion and its direct effect on satisfaction are scarce. In this respect, the present work is providing new insights, revealing the parameters enhancing satisfaction with the augmented reality experience. Concerning the purchase experience, the quality of information has a positive relationship with the perceived utilitarian value, while aesthetic quality had a positive relationship with the perceived hedonic value. Quality of information has a significant impact on attitudes, as already shown on previous studies. While information is a crucial parameter in user experience evaluation, aesthetic quality affects the user experience and attitudes towards augmented realities. Concerning utilitarian and hedonic value and their effect on purchase intention and product knowledge, we have been able to substantiate hypotheses 5 and 6. Enjoyable augmented reality experience is already reported to increase brand engagement and purchase intention. Consumers who like experience better are more likely to continue with and to recommend the experience. Hereby, we have been able to show that both utilitarian and hedonic aspects are crucial in shaping the purchase journey. Few take-home messages. The present paper investigated the key drivers of augmented reality experience and how this may enhance the purchase experience itself. Augmented experience evaluation in terms of user satisfaction correlates with interactivity, realism, ease of use, and immersion. Purchase experience correlates with utilitarian and hedonic values predetermined by aesthetic and information quality. Utilitarian and hedonic values positively affected the product knowledge. These findings offer a holistic framework, providing new insights on augmented reality experience and therefore shed the much needed light on parameters hypothesized to affect the purchase experience itself. And this could be directly applied in practices to design appropriate augmented reality applications to enhance the consumer journey. Hereby the core references, but I would recommend you to read the entire paper also in case you have questions. I'm looking forward to your comments. For now, I thank you for your attention.
Okay, thank you very much, Svetlana, for this first talk. Are there any questions you want to just give a try right away? Otherwise, I would just like to ask you, Svetlana, to show us the second talk video.
Hi, my name is Svetlana.
So entitled From Attention to Action, Key Drivers to Augment VR Experience for Everyday Consumer Application. So please feel free to continue writing down all your questions into the document, which we can then, I guess, also in combination with this talk discuss afterwards, simply because I think the topic is more or less similar. Of course, the work are different. So please, Svetlana, get the video rolling.
Thank you.
Lana Bialkova, and I'm a senior lecturer in digital marketing at the Liverpool John Moores University. Today I'm presenting a talk From Attention to Action, Key Drivers to Augment Virtual Reality Experience for Everyday Consumer Applications. Why this talk? Well, we are witnessing an uprise of augmented virtual reality technologies applications for marketing, advertising, branding, and commerce. However, there is a lack of understanding on the fundamental processes underlying human behavior, from attention to action between virtual and real worlds. There is also an emergent need to understand and reconsider existing virtual reality theories and meet this with marketing strategies. Therefore, we came with the current study to better understand the consumer demands and brand consumer dynamics in creating immersive and engaging experiences. We created a framework from attention to action in order to actually enrich the marketing space incorporating augmented virtual enhanced reality applications. How to best communicate values to bring user into the brand world, and how to optimize the user experience, inspiring and forgettable consumer journey are the crucial questions we addressed with the current study. First of all, I provide some overview on marketing in virtual worlds. Why this inspiration came? Well, we are interested to enhance the brand value within virtual worlds. And there have been a couple of examples from literature supporting the notion that there is increased product knowledge and attitudes, creation of enhanced brand awareness when virtual reality is used. Also to mediate customer loyalty. Therefore, the crucial question we address is how to build brand equity and to navigate the purchase intention in virtual worlds. Because also some skepticism arises that consumers, despite enjoying the virtual reality experience, they are not buying the virtual products in the real world. Yet the question is how to enhance the brand value and to navigate the purchase. Well, through experiential journey, offering consumers enhanced journey, through activating various perceptual modalities, or integrating multi-touch points at different stages of the consumer journey, and thus offering engaging and memorable experience. It's well known from literature that increased enjoyment, attractiveness, and satisfaction lead to not simply purchasing the product, but more important, to loyal customers who are advocating the brand, the experience, the product. And this is what we need. The question is how to enhance the journey, how to augment experience. Hereby a couple of examples from brand leaders on different augmented and virtual reality applications. Also some examples from our lab. The questions we addressed in such kind of augmentation is how consumers could be engaged in the virtual worlds. How do they interact with the brand and how do they interact with each other, and what are the factors driving the above interaction? Well, attractiveness and enjoyment of virtual reality experience tends to be modulated by the background information and environmental factors. Furthermore, multisensory integration enhances the experiences, like in some of the studies we've confirmed from our labs. Integrating music turns to actually reflect the higher engagement and liking of the experience. Based on these notions and practical examples, we have developed a theoretical framework encompassing behavior from attention to action. Stepping on classical literature from marketing, psychology, usability, virtual reality, we are developing the framework in order to better understand the behavior from attention to action. We are in particularly interested how the virtual world is perceived and enhance the consumer behavior. Perception, define it as organization of the information, depends on actually sensorial breadth and depth. Sensation is coming from different modalities. The brains are constantly updated from information coming from vision, audition, olfaction, somatosensory, even gustatory nowadays mechanisms could be incorporated in virtual and augmented reality applications. In order that information is actually perceived, it should be attended. Attention is the bottleneck. Attention coming from different environmental characteristics, visual, sound, smell, material, or taste, could be selective. Selectivity of attention could be either goal-directed, depending on the goals of the consumers, or determined by bottom-up mechanisms, namely the most salient information within the environment is attracting the attention. Once the information is attained, it's further processed for cognitive action, performing senses and percepts. It's crucial to understand actually how consumers are perceiving the naturalness presence of the environment. Despite the fact that scientists are not univocal on the parameters characterizing the virtual environment experience, hereby I highlight some of these parameters emerging in a couple of studies, and therefore we define it as crucial to be taken into account when exploring perception of the environment, namely naturalness, presence, immersion, vividness, interactivity, engagement, as well as the social component. The way the environment is perceived will further determine the action taken by consumers in terms of cognitive response, but as well as the emotional response. How consumers actually act and interact with the virtual reality system will feed back to the way the system is perceived. So we are considering a loop in between these two stages of the model. A further question one may ask could be, hey, but what is the relation with the consumer behavior? Well, we assume that from attention to action, it's crucial to understand the mechanisms underlying behavior in pre-purchase, purchase, and post-purchase stage. Furthermore, once consumers buy a product, they are returning for the pre-purchase again stage. But think whether the process is linear, whether consumers are looping, or there are different pathways. I'm really curious to hearing your opinion and questions challenging the model I just presented. To further support the model, of course, we did experimental studies. In one line of research, we've been looking at multisensory processing of information, in particular how audio modalities are enhancing the visual experience. And we have found that, in fact, music evokes very complex responses and may alter behavior when consumers are exposed to virtual reality environments. Integrating music within the environment may augment the experience, reflecting in higher engagement in liking. Another line of research explored the impact of environmental factors, how they enhance the perception and the further cognitive and affective response by our consumers. We have found that background information modulates the way virtual reality environment is perceived, furthermore reflecting the attractiveness and enjoyment of the virtual reality experiences, which is crucial for the next stage, namely how consumers like the experience, but how do they return to the brand? How do they evaluate the brand, the product, and the company? So it's really important to understand the entire process from attention to action and the returning customers. This is important to have practical implications, which is the crucial point of this model. Few points I would like to bring your attention to today, namely applying multisensory experiences. The more senses are involved, the higher the enhancement of the experience will be. Think also in direction of collaboration, especially social interactions turn to be crucial for enhanced augmented and virtual reality experiences and to lift the brand value. Lifting of experience came also from dynamical experiences, and hereby another example coming from the last year IEEE VR conference with the dance event. I think that all of us enjoyed this fantastic opportunity. And one more advice coming from today is the global cloud. Only through global cloud integration, it's possible to actually enhance experience. And this is the opportunity we have with the augmented and virtual reality technologies, opening avenues for marketing of the future. Key references, but I look forward to your questions and hope you read the paper. So very curious about your opinion. For now, I thank you for your attention.
Okay, excellent. Thank you very much, Svetlana. So as I see, there are some questions piling up. So I would like to take the opportunity to raise a question for you two talks, and then I will simply hand over back to you to discuss the other question that came up for the first two talks. Is that fine with you, Svetlana?
To start with answering the questions, or
Yes.
we start
Both.
with?
We will start with answering your questions for your talks, and then continue with the other ones.
I see one question. One challenge do you foresee regarding try-on experience for other type of products? What aesthetic quality would you consider the most significant when representing such products? That's a really fantastic question, and I must say that the good point of the entire experiment. Now I'm talking about the first talk, augmented reality presentation, the virtual try-on, where we've been exploring products from fashion, in fact, beauty, imaginary task by a lipstick. So we had quite a lot of aesthetic quality hereby, but the aesthetic quality was on the web page itself. And this is really relevant to test the model on another type of products, another brand, and to see whether the model works. And we, at the moment, are running another experiment, virtual try-on with glasses, one of the leading brands, again, here in UK. And we see that aesthetic quality is indeed problematic, depending on the type of the product, but it's really related to the way the brand organizes the content. So aesthetic quality is a crucial parameter indeed, and it reflects the type of the product, the type of the brand. So the model works and reflects that brands should take care of the way the information is propagated. But what I have to mention here by the importance of such kind of experiments and why we did it, such kind of experiments, is because indeed you guys from computer science are developing fantastic opportunities for virtual and augmented reality applications. From other side, it's us, consumer scientists, marketing scientists who try to apply these applications. And it's really time to meet together efforts in order to develop such kind of applications which could be applied in the real life scenarios, because it seems that consumers are still resistant, and we need reconsideration of theories and models, which are the factors enhancing the experience. From one side, the technological aspects, from other side, the consumer experience, and how this both interact in order that we enhance the experience for customers for everyday applications. That's what the first talk. Would it try technology still be applicable if the consumer was also in a position to try the product in real life? So what advantage would the try-on technologies provide? I'm talking now of the second talk. There is a question, but actually they are interrelated. So if I understand correctly, the question is how actually there is interrelation between virtual and real world. Yeah. I'm still, someone is still writing, so. That's another very nice question. Yes, we had this, maybe I have to read the question so everyone understands why I'm laughing. One of the questions that came hereby is, if so, what the advantage would be if technologies provided, and would consumers ever choose try-on versus real life? In the experiment that we are currently running with the new products, these are glasses. We've been asking people to buy sunglasses or just regular glasses if they wear glasses. And then we had a couple of extra questions at the end and asked, do they prefer a virtual reality front of physical store visit? Do they prefer 2D web pages front of virtual reality? And what we discovered, that still consumers prefer to go physically to visit the store. Then we have virtual try-on, and at the end we have just regular web pages for ordering products. So there is improvement because 3D technology is the virtual try-on is preferred front of simply online shopping, but there is still room for improvement so that consumers prefer virtual try-on. And also they mentioned it because here in UK was a really heavy lockdown. A lot of participants mentioned that in fact they bought glasses during the lockdown through virtual try-on because it was simply not possible to visit the store. So sometimes the convenience is also a crucial factor, and this should be taken into account. But from a technical perspective, there are also opportunities for improvement. I think we should go to other questions, to other speakers, because I've been talking too much. And maybe it's nice to also give the floor to other speakers.
If you don't mind, I would just like to raise one further additional question to Daniel, to his first talk in the session, because he was raising this point also. So the question came from me regarding the orientation aspect, and I was wondering, and you said also you plan to extend your research on this and also try to measure like cognitive maps and such. And I'm wondering whether you have a good plan how you're going to measure this, because we did this in past research, and that's a very, very hard thing to do, to externalize, right? These kinds of cognitive representation of environment or whatever this is generating, or orientation in the cognitive apparatus of the human.
I'd certainly appreciate a suggestion if you have one. My thought was to have them actually try to draw a map of the environment. And obviously, if the environment is very complex, that's going to be super challenging. But if it's somewhat more grid-like in nature, it's a little bit more possible. So what I was thinking is develop an environment that would, I think, be feasible for the people to actually kind of learn in their mind and be able to draw a map that in some sense we could grade and then mark the locations of targets on the map. That's what I was thinking.
That's also what we did. So, but we only had the point that we had only one room, and we had to ask people to remember where specific elements are located. Right. That was kind of, and that's also another aspect. It's not orientation in the best sense, but what you may also could do is to ask people to remember things. So having like a questionnaire asking for, did you see this and that? Can you remember where this was located related to the other thing? And you may also consider like the standard wayfinding aspects like waypoints and such, to ask whether they received that and can probably then describe. Or you may also ask for like, describe the way from A to B. That might be also interesting to have something. But I think that's a very big challenge to like externalize cognitive maps, specifically because they are often not complete, but like continuously updated during maneuvering or moving through environments.
So I had two other thoughts. One was related to your first question. If you go back and look at the paper and the data, the method that allowed people to travel the furthest, the hand selection is what we called it, but basically they could gesture to a faraway object and jump to it. That was the one that seemed to be the most disorienting to people, the one that most likely would cause them to turn around and go the wrong direction. If they made a big jump and after the teleport, they were standing right at a wall, sometimes they would turn the wrong direction and start going back down the hallway and then realize the arrows are pointing in the other way, and they would get oriented. We were trying to not have people get disoriented in the study, which is why we put the arrows there, but it did make me start to think, maybe the further that they jump, the further the teleport, the more the disorientation. But then I guess the second point is, it really depends on the application. Sometimes it doesn't really matter. You just want to get to another spot as fast as you can. So who does it really matter if you don't understand the structure of the environment? But in environments where you do, it is kind of important to learn where things are. Maybe a different teleportation method would be appropriate.
I think another point would be just thinking about what the actual question is, right? Is it considering teleportation as a method which does hinder to build up cognitive maps? Or is teleportation hindering orientation when you have a good cognitive map? That would be another question, right? That people have a good understanding of the environment and can orient themselves, and then they have to teleport, and then you have to ask, okay, are you going to be disoriented using teleportation in an environment that you actually know pretty well or not, whatever. So you will not come around the measuring problem that you have to measure the quality of the cognitive map somehow, right? For the first and the second question. But this might be also another direction which might be interesting there, right? Because I can imagine that both aspects are interesting, but have different kinds of elements. Probably for the first one, teleportation would be worse than for the second question. Yeah.
Yeah, thank you. I appreciate that.
Good. So I'm handing back to Svetlana. You're muted. Yes.
Yeah,
okay. No.
I've realized that. Yeah, I think that there was a question also for Yongkang.
Yes, I already sent into because that Jimmy asked me about some related research for the WEVR for this kind of the research. So I already shared the link in the chat box that will be about the web-based VR questionnaire page designed to improve the user experience. This paper is published in VRST in December, just a very fresh paper. Yeah, because these days not too many researchers research this web-based VR the research, just some poster or some paper. I think not too many people to do this area. Yeah. Okay, thank you.
That's the good point. Opening new challenges or new opportunities with the research that you've done so far. Good. Then do we have more questions? From the audience about the talks?
And still feel free to continue discussion in the Discord channel, by the way, right? So if there are any further questions later on, just post them there. And I think all authors are happy to stop by and probably post an answer. Otherwise, I think we're done with the paper session, right? Okay, so Adal is back, I guess. Is it, Svetlana?
Yeah,
he's still there. He's still
I've
alive.
been here for the whole time. Yeah, it's almost 2 a.m. here. So. Yeah, I guess, I don't know, do you want to have like a closing session, or should we just stop?
So for me, it will be a sleeping session. So I will go right to bed, I guess. Unfortunately, I cannot join the last workshops, but I'm too tired.
Yeah, me too. We should have had an American or New Zealandish organizer so that he could continue. Yeah, so I will also have to close here. The bed is waiting for me. All right, so thanks. I guess we can thank the audience now who has made it so far to attend the workshop, and our authors here. Yeah, so keep following the Discord channel for more initiatives related to the workshop, and would like to thank you again for listening so far, and see you hopefully in person really soon. Okay.
Thank you all. Bye-bye.
Bye-bye.
Thank you.
Thank you, guys. Bye-bye.